Hi and welcome to another video on reduced CO2. Now, I'm Thomas and today we are looking at CO2 budgets. And there's really something in these budgets that could be really seen as very misleading. And you could be also saying that some people are trying to hide something or it's a conspiracy or something. No, but we are looking now at science and figures, but there are some really important facts inside, so stay tuned. And we start by, well, you probably have heard like the Paris Agreement, and you have heard of these 1.5 degree targets or 2 degree targets and stuff like this. And this is like, people came together and said, hey, we want to, have global warming not reach really high levels. So we want to say, hey, we want to keep it well below 2 degrees. So they came up with a target of 1.5 degrees. And so now the problem is, they asked the scientists, okay, if we want to have if we don't want to exceed 2 degrees within the year 2100, tell us how much CO2 there can be in the air, and then we can calculate how much we can still produce and how fast we have to change. The problem with this question is, it's actually already too late to achieve 1.5 or 2 degrees. It's like my summary, But so they came up with a scheme which is like really, really interesting. You will see this, and it's all like rules. Let's bear with me. We are just looking at data and science. So first of all, this is like a diagram where you see here. This is the amount of CO2 produced in gigatons per year. So this goes up all the time. This is the gigatons per year. This is how much CO2 we as humans put in the air. And the black one is the graph, what we have been producing. And already, this is already outdated, but the green line would be the 1.5 degree target, and the red line there is a 2 degree target, and then there's 1.7 degrees here as well. So, and this is coming from a calculation saying, okay, we have already put into the air, and we can measure the CO2 concentration in the atmosphere right now, which is like 425 end of last year. So we know how much we are putting out in the all the time. So, and then they ask the scientists, how much is still our budget? How much we can still put out there, So, and then they came up and said, okay, the budget is like, if you want to achieve the 1.5 degree target, it's somewhere around some 100 tons. Here it's 235. And this means with the production rate we have right now, this is like only some years. So it would say within some years, we would have to go to 0. And then we could achieve 1.5 degree warming. Okay, but you see that getting the world from producing really much, and this is like, here is COVID, this small blip here is COVID. So that has to be a so radical shift. Nobody can really believe that if you see these figures. 1.7 degrees, yeah. And now you see, okay, this is like a really long time scale here, 2100. So it's like, it's like now 50 years or so. Here's the year 275 or so, 2075. So this is like 50 years here going down from where we are to 0. So you could say, that's sort of achievable because we have like 1,100 gigatons left. This is this diagram is telling you this. So you say, it's good. We just, we have a budget. It's like, we have like 1,000 something, and currently we are producing like 40 per year. So we have like 25 years budget left, and you go down, so you get to these 50 years, it's manageable, right? You have the answer. It's like, it's still working. Huh? Well, the problem is, now comes the rules, or, in German it's Verarschung, but, I didn't look this up. It's like, hey, if people show you such a diagram, they don't really tell you often. Or of course, in the papers, there is this, yeah? But they don't really tell you that they come up with these figures thinking of a certain probability, because predicting the future isn't really that simple. And like in psychology, for example, we always work with, probabilities. We say, there's like a bell curve, and you have certain people here in the middle, and there's a probability of this. So you always use this, oh, it's not fixed humans, it's like a probability for something. With the climate, predicting how high the temperature, the global temperature in the year 2100 is extremely complicated. There are really small factors, and I don't want to be in the shoes of the climate people making all these modules using supercomputers and trying to predict the future. So, but the problem is these graphs are made with a certain probability. How high do you think this probability is? You can stop the video and put in the comments now, how high do you think this probability? Okay, the probability is 50%. So we have a 50% chance of actually staying below 2 degrees. There's a 50% chance if we do this here, which already from the point of view of like what we see so far is unrealistic. But there's another story, is we want to talk about this budget. It's with a 50% chance. Let me know, would you step into an aircraft where the company who is flying you is saying like, oh, with a 50% chance you're going to arrive at the destination, maybe you're going to be dead. Would you take this aircraft? Probably not. When the first astronauts, like in Mercury, Gemini, and Apollo and so, when these guys were going into space, they knew that maybe their chances of survival are in this area. You can't really think of the first astronauts more than, these rockets were blowing up all the time at this time. These people, the first, the Mercury 7, these people, they were taking this job and they knew they are maybe going to die when they have like a 50% chance, and they still took it. But that's why like really extreme people, and it turned out that, it was better than 50%. But astronauts, you're still like taking a job where it's not a 99.99 something like when you travel with an aircraft. No. But these diagrams are made with 50%. There's like a little bit different figures for these ones, and they are made with 67%. And then say, this is likely, 67%. Now we come to the real problem, and I haven't printed out the diagram yet. I'm going to show you this. This is a very fancy diagram, and you really have to look it up. It's on my LinkedIn page for Reduce CO2 now. There's this page, and there's a special. This is even for the CO2 budget, because that thing is really explaining how this whole thing works. It's we have a line here of the CO2 concentration, and the dashed line here is 425. It's like where we are today, or 420. And now the really nice colors here, which are telling you how high the percentage is to achieve a certain warming. So here you have degrees Celsius or Kelvin, not Fahrenheit, Celsius. And here's a 2-degree target. Okay, so, and now these lines are saying, okay, if we have a certain concentration, we are going to have a certain warming, and a certain probability with this. Okay, so really nice thing. Look this up really on the computer, So you have the CO2 concentrations here, which are going up, and you have the warming here, and you actually go there, and then you find out, okay, to be on a 2-degree level, and you have this kind of CO2 concentration, what kind of probability do you have? Oh, so it says, okay, we have like a 66% probability. If we are like with this, where the dashed line is, and with 420, and we have 2 degrees, we achieve something like a 66% probability that we are below 2 degrees. Oh, that's good, we are 66. But wait, we are still producing CO2. Huh? So we have to go even higher, and then find out, okay, there's like the 50% line. We take that one, and then we can still produce that we go up to something between 450. Yeah, the only problem is that this chart is, it's CO2 equivalent, so it takes out other greenhouse gases as well. But it's just like to show you the problem that the probabilities here and the temperatures are linked. And now if you would say, if I would say I want to have a prediction, there should be something like 80%, like Pareto principle is 80%. Or, like if you want to be saying, 90% seems good, or 95% in psychology, there's like this 95% where you say, okay, like if we take like 95% of the population, that's like a good thing. We have this 95% marker there, yeah? That's like a value where you say, oh, that seems to be a quite good value. But, you see how that, this line, the dark blue line is a 95%. So, what is like our prediction to be staying below the values of today? Okay, so if we just look, the dashed line is like where we are today, and then you see how the 95 prediction is, we are staying with a 95% probability. With the current levels, we are staying below 3.7 or so degrees. It's not 4, it's like 3.7. We are limiting the warming with a 95% chance with the current levels to 3.7 degrees. Isn't that great? So far we are looking at 2 degrees, okay, let's take something like a little bit more, let's take 450, yeah? So we take a little bit more, we go to the side, and then, you take a little bit more, you are at 4 degrees with 95%, yeah? Or, if you take like the current line and say, okay, 90% probability is all right. And then you take the current line and you are like at 3 degrees. Yeah? So, with a 90% chance, we are not going to exceed 3 degrees. Or with a 95% chance, we are not exceeding 3.7 degrees warming. So that is what the diagram is telling you. It's telling you that, there are, the probabilities and the temperatures are linked. Yeah? So, what does it actually tell us? Of course, you can't get a scientist, and no scientist will tell you have such amount of CO2 in the air. It's not going to be warmer than this, because we have like data from history, which is like this, because it tells you, hey, where we are today, this is again the dashed line, this is the CO2 concentrations on the planet today. And if you look in prehistoric times, and people found, okay, what were the temperatures in prehistoric times? This is like 65 million years ago. You can also see what kind of temperatures have been there. And there, the temperatures associated with our kind of CO2 levels we have today are around like 4 to 5 degrees more than pre-industrialization. That's like the problem. If you really look back in time, where you correlate, where you say, hey, here the world has been in a sort of an equilibrium for some time. We have some data from history. And of course, that took like thousands and millions of years to change. We say, here it was really warm. Where we go with 720, it's like one scenario. You see that you're going back into things with 720 in areas of, it's going to be 6, 7, 8 degrees warmer. This is data we have from prehistoric past. Can we take this one-to-one today? No, of course not. Is it going to happen within like the time frame of 2100? Also no, but saying I'm going to use diagrams which are using a 50% probability is like, I think, really misleading. Because if I would say, hey, I want to have the figures now for, let's take 80% or let's take 90%. 90% seems like a good figure, isn't it? Like 90% chance, would you go in an aircraft where 9 times out of 10 you arrive at the destinations and 1 time you die? Not really, yeah. But these kind of curves become much more steeper. And actually, if you want to have a 90% kind of now we go backwards. No, we try the other way. So we say, hey, we want to see the 90%, 90%. And then that's really an exercise. We say, let's assume, we don't go for the 95. We just take the 90. Yeah? So you take this line, you go down, and you go to the 2 degrees, which is again here. So you see that that kind of level is roughly 350 parts per million. We are already 425. So the problem is there is no budget. This is a problem. That's what the people there who try to make out these kind of we are going to have targets. They said, hey, we are going to set a fancy target. It really sounds good if we say 2 degrees and we want to be able to do 1.5 degrees. We want to be well below that. And then they told the scientists, hey, scientists, we need how much can we still produce where we have where we produce these 2 degrees or 1.5 degrees. The only problem was the scientists said, hey, there is no freaking way that with any kind of certainty you're not going to exceed that. You're very, very likely going to exceed that, because if you have a 50% chance that you make it below this value, there's a 50% that you exceed it. Yeah? So all these diagrams would have said, hey, we have to go backwards, we have to go negative, and we have to sequester we have to get CO2 out from the air. Because if you say, hey, I want to have a 2 degree target, which is if I want to be in 2 degrees, and I want to have 2 degrees and 95%, I have to be something like 350. So we have to go below the curve, get CO2 out of the air for all this time to achieve that we are not exceeding this with a 90% chance. So the actual diagram would be zip, go down and come and get CO2 out of the air that we go to 350. If you want to have a 95% chance, which is 95, if I would fly with an aircraft and they give me 95% chance, I might, be inclined to actually take it, but it's still 1 in 20 flights you're going to die. It's not such a good thing. It's if you're doing this wingsuit thinking thing, it's similar. You crash all the time, and even those guys do better as 1 in 20. So 1 in 20 dying is Formula 1 in this 97. That was even better. So if you want to have a 95% chance and you look at this diagram, you're with a 2 degree target, you're coming out with 335 or so. It's roughly 90 units below today. So that's the problem. I think that the politicians were saying, hey, we want to present the world a nice target, what everybody says, yeah, we well below 2 degrees. The wording, they already knew that 1.5 degrees is already out of the door with a certain certainty. So they came up with, hey, but how can we make it that we can still produce something and put the problem somewhere in the future? Yeah? And then they said, yeah, well, because the scientists were already talking to them in the sense of probability, and then they said, yeah, okay, but if you lower the probability, where do you come then? And then they said, yeah, 50% is like this. Oh, we take that 50%, and then you come to this figure. In 50% of the cases, oh, we are fine off, we still can produce something. It's going to be 50 years. Don't worry. The problem is not that it has to be solved now. It's you put it in the future. And the trick is, the gimmick was, hey, we just lower the probability enough that people think, oh, that's fine. And when they're talking about these diagrams, they say 50% it's likely, or they have likely or very likely. Yeah. Think of the aircraft. Would you go into an aircraft and fly with an aircraft which is likely or very likely going to be carrying you to your destination? So, thank you very much for watching. We really have to do something about this. You can leave a like and subscribe, and also leave a comment. And, what kind of probability would you take to actually go in the aircraft? Thank you very much for watching.